Question 6. Consider the following two statements about the polynomial fx. So P is saying fx equals 0 for exactly 3 real values of x, so 3 real roots. Yeah? And Q is saying f prime x equals 0 for exactly 2 real values of x. So that's saying, okay, 2 stationary points, right? Which one of the following is correct? Okay, so it's asking about necessary and sufficient conditions, right? Okay, so let's check then. We just have to check the implications both ways. Yeah. So let's check P implies Q first. All right. P implies Q. So is this true? So if we think it's true, we need to give a proof. Assuming P is true, we have to prove that Q is also true. Or if it's false, we give a counterexample. So again, the strategy is when we don't know if it's true or not, try some examples first, right? So fx equals 0 for exactly 3 values of x. Okay. So well, you know, the most intuitive thing to do is a cubic, right? Okay, so 1, 2, 3, 3 real roots. That satisfies Q, right? Okay, so that's not a counterexample. All right, remember, this is not a proof. Okay, this is just an example, but it's not a counterexample. Okay, anything else we can do though? So instead of cubics, you know, for it to have 3 real roots, you definitely need a cubic or above, right? You need a quartic or quintic or something, right? So let's try to draw a quartic with 3 real values. So let's say like this. If it has a repeated root somewhere, right? That has 3 real roots. Yeah. Okay, but then it has 3 stationary points as well. All right. So I found a counterexample. So P does not imply Q, right? So not sufficient. Right. This way of the arrow is sufficient, right? So not sufficient. Good. Okay. The other way then. Q implies P. Okay, so let's see then. So again, let's assume Q is true first. So does that imply P? Okay, so again, if you have 2 stationary points, then you might draw a cubic, right? So if I use the same cubic again, well, this satisfies both P and Q, right? So this is not a counterexample, as I just said above. Well, what you could do though is that, well, I'm going to use the same cubic, okay? But I'm going to move this up a bit, okay? I'm going to make a transformation such that I do this. Well, this still satisfies Q, right? It still has 2 longs, right? It still has these 2 stationary points, but then now it only has 1 real root, right? So Q does not imply P, right? So P is not necessary for Q. All right, makes sense? So not necessary and not sufficient. So final answer would be D.